Hello, everyone. This is just kind of a short video just to go over solving word problems. As you notice, I have the two trains from right here. So I'm just going to go ahead and read it again. And we're going to go ahead and follow through the steps I've talked about in order to go ahead and show you how we're going to do this. I'm going to solve this by graphing just to make it short, and I expect you guys to do the same with your own problem, which you're going to go ahead and do next. So let's go ahead and get started. Let's read through the problem very quickly just so we can understand. We have two trains and they leave different cities heading towards each other at different speeds. Train A, traveling at 70 meters per second, leaves Westford heading towards Eastford at 2,600 meters. Okay, so that's the distance between them. At the same time, train B, traveling 60 meters per second, leaves Eastford heading towards Westford. When do the two trains meet, and how far from each city do they meet? Okay, so we got several steps here. First thing, I always say, just kind of take a breath. Just be confident. You know, that mindfulness thing that we've been throwing at you. And we're actually going to go ahead and get started by going through this problem and trying to figure out what every part means. So first thing, what is the problem about? Well, I'm going to go ahead and draw it in this small box here. In fact, I'm going to give myself a little more room. So that way I can go ahead and actually do the drawing. Okay, but I have my pen here. And we basically have a tale of two cities, or two trains. So here we go. I'm going to draw two dots here. And just so we can understand the problem, I'm going to go ahead and draw it out. I find this to be an important step just to help me understand what exactly is going on. So I got two towns. I got Eastford, right? And I got Westford. Okay, now, why am I drawing Eastford and Westford? Well, because it's easier to start off with the objects that are not moving in physics. Because if you start with the objects that are not moving, then you can actually you can focus on those, and then after you can go ahead and focus on the objects that are moving. So these are kind of just my set points. Now, when I go ahead and actually look through this, I notice there's several things. Number one, that there is a certain distance between these two towns. Okay. So there is a certain distance. I'm going to entitle that X. And we got a train A, and it's leaving Westford heading towards Eastford. Okay, well, I can go ahead and do that. I'm going to do this in a different color. I'm going to do it in green. And here's train A, right? And it's moving from Westford going to Eastford, okay? Got it. And then at the same time that is launched, okay, so I have that. We got this thing, and we got basically this train B, which is traveling 60 meters per second, and it's leaving Eastford heading towards Westford. Okay, so I'm going to go ahead and draw this in, let's see, I got orange here. I'm going to go ahead and do this in orange, and this is train B. And you know what, I'm going to actually go ahead. Okay, so I have that, and this is kind of the basic situation. You have very much like the two droids. You got these two things, they're heading towards each other, and we know at some point in the middle, they're going to meet, okay? So let me go ahead. I can actually insert values now. So I got train B. It's heading at 60 meters per second. Okay, cool. And then after I got train A, traveling at 70 meters per second. Okay, and then after, I got this X here, which is 2,600 meters, okay? No big deal, that's step 2. Okay, so what's this problem about? We got two trains heading toward each other, different speeds, and this distance between them, and we want to know something. Okay, so let's go move on to step 3. So what is the question asking for? Well, I'm going to go ahead and highlight And usually I find this sometimes I find this handy, especially, as the problems get more difficult. I want to actually know what exactly I want to go ahead and do. So I'm going to highlight or bold whatever I want to say. So you notice there's two questions here at the end. Okay. I'm asking, and I know this may be hard to see, when do the two trains meet? Okay, so that'll be question 1. You know what? I'm going to put that in bold. I'm going to make that, let's make this a red. Okay. And then after, we want to know how far from each city do they meet. Okay, well, that question is going to be a little harder because notice it's not like where on the number line do they meet. It's how far from Eastford do you meet and how far from Westford do you meet. So this is actually two separate. This is going to get me actually 3 separate values. So I'm going to go ahead and actually highlight this again. Oh, and I actually am going to make this, let's make this green. Okay. Okay, so, and actually I'm going to go ahead and say, okay, so part A is going to be this, right? I want to know when do they meet. So at what time do they meet? So time of intercept or time meeting. Okay, I'm going to go ahead and add another below. Okay, and then after I want to know distance from Eastford. Because you notice it's not like saying where from they meet, it's how far from each city do they meet. So this is why it's important to read the problem carefully. Because if you did do that, you would have missed that, and that would have been a problem. You would have not passed this. Okay, and then distance from Westford is the other question. Okay. All right. Okay. As I said before, I kind of just highlighted some key values here. Okay, so that's step 3. I'm going to go move on to step 4. I'm just going to also highlight some step key values. Okay. Let's go ahead, and I'm going to highlight them all in various shades of blue here. So first of all, I'm going to bold this. So we have train A, and it's traveling at 70 meters per second. Okay, so there we go. Train A, traveling at 70 meters per second. Right, now, here's the thing, right? We know that this train is moving one way. Ooh, wow, that is way too light. I'm sorry, I'm going to make this a darker blue. There we go. Okay, and it leaves Westford heading towards Eastford. Okay, now here's the problem though, and you've probably already seen this. These two trains are traveling in very different directions, so I'm going to have to denote a 0 at some point. I'm going to go ahead and get into that in a moment. But let me go ahead and highlight the other train. We got 2,600 meters. Okay, that's an important value because that tells me the displacement that these two trains will do. And then after I got train B. Okay, and I got train B, which is measuring at that. Okay, so I got this. Cool, so I got these. Okay, so I got 3 main values I'm dealing with. This value, 60 meters per second, 70 meters per second. As I said before, one of them is going to have to be negative. I'm going to actually save that, hang on to it for just a little bit longer. I just want to go ahead. I want to make it step 5 first. Step 5 equations. So let's actually think about it. Okay, so if we have this, what are the equations we're dealing with? Well, obviously, we are graphing this. So velocity is going to be involved. Okay, so v equals to delta x over t. Okay, it's going to be involved. Of course, if we're drawing graphs, though, that's going to actually go ahead and we can rearrange it to x naught. Sorry, x naught x equals to v t times time plus whatever x naught is. Now, here's the thing about x naught, right? In both of these equations, well, in one of these equations, one of them has to be 0, okay? So I think we can go ahead and let's actually start by establishing which is which. So I'm going to go ahead and let's draw the equation for number A. and then we'll do it for B. I'm sorry, Control Z, below, below. Okay, cool. Let's do this. Okay, so let's do it for train A. Let's do this. Okay. But let's bring out our pen, and I'm going to decide on a 0 point. Okay, now this can be tricky, but you know what? Eastward to westward makes sense. And because I want to establish an x naught somewhere for train A, I'm going to declare this to be 0. Okay, so 0 is going to be at eastward. And that makes sense. And anything that's going from here to here is going to be positive. Okay, so this is going to be positive 260. Okay. And I'm moving in a positive direction. So this is going to be positive 660. Okay. That makes sense, right? Because it's going up the number line. Okay, let's go ahead and take a look at this. Now, because this train is moving down the number line, this is going to be negative 70. And notice my x naught here is actually going to be an interesting value. X naught for A, right, where I start from A, is not going to be 0. It's going to be 2,600. Okay? And this only applies to A. So sub naught A. We have weird notations. Okay? And this is all just taking care of the vector math here, because you notice as we do the graphs, as we've seen with the droids, you're going to have one thing that's going to go one way, one thing that's going to go the other. So I'm going to go ahead and just very quickly do my equation here. So for train A, well, we're just going to plug in values. So my x value, right? So where I am in space is going to be dependent on my velocity. In this case, negative 70 meters per second. Negative 70, do note, negative is very important, times whatever time we're at, plus our distance, our initial value of 2,600. Okay? That makes sense, right? Because we go start here, move down here at this rate. Okay, let's do train B. Okay. And you notice train B is the opposite situation. If we go ahead and look at train B, number one, x naught, here, for B, is 0. Okay, so that's easy. And we notice we have a positive 60 because we go up our number line. Okay, so let's do this. X equals to 60, positive 60. In fact, I'm going to actually emphasize positive. Now, do note this is at your own discretion. If you decide to do this way and start here and go towards eastward, well, you could have done that, yes, but you have to flip the entire system to reflect that. So you do have that power of choosing where you are. Okay. Plus 60, and then after you start at 0, of course, you could always shorthand this to make it simpler for you. And you could say x equals to 60t. And that makes sense because for every second that passes, you're going to go up the number line until you get to this number. Okay, now we could spend time solving this system of equations that I've established here, or we can just go ahead and jump into actually just going ahead and trying to figure out what's actually going on. And we can actually solve this. So the way I'm going to do that is actually I'm going to make a short table here. And because I know several things, I can actually go ahead and I have these equations, I can actually go ahead and use them to my advantage to solve this. So let's go ahead. I'm going to start off, and I'm just going to plug in one or two values so that way I can make a line chart and I can figure out where and when they land. So let's do one for train A. Actually, first column is going to be time. Train A. And train B. Okay, and notice this is going to be easy because Excel has certain features. So we're going to do it 1, 2, and 3. Okay, so I don't know if you know anything about Excel programming, but there's certain ways we can do this. So basically, I'm going to say, okay, let's go ahead and do, well, we'll just have to do a little math, but notice it's plug and play at this point. So let's see, 2060. Okay, well, we're going to say that this square is going to equal to 2600 minus 70. But I probably should put this in parentheses so that way my calculator doesn't get confused. Multiplied by whatever time it is. Now, the time, fortunately, is whatever's in this box. A19, right? That makes sense. Okay, cool. Boom. Okay, so that's all did the math for me. And I repeat that step and I do the math for the rest of them. So this time, you notice this time for time 2, right? So 820 and square root 20 is 2 seconds. Then I do it for 3 seconds. Okay, that's cool. Okay, same thing for this square. And I can use the equation here myself, right? Desmos. You're going to love Desmos because Desmos actually has the same idea. You can actually do the same thing on Desmos. But you can actually go ahead and, yeah, do this. So 60, right, times the time value. Well, we start off with time 1, right? So let's go ahead. 60 multiplied times time 1 is this square. So 1 second. And that obviously equals 60, right? Then we got 120, 180, and so on and so on. So it's just basically multiplying the velocity plus your x naught is going to get you these values. Okay, and you can look through the equation here. So 2,600 minus 70 times the time, which was 1 second here, that gets you this value. Okay, cool. Okay, so now I just need to solve by graphing. Let's go ahead and do that. You guys know this step. Notice I saved a lot of time here. Okay, let's insert a chart here. Oh, wow. Okay, so we're obviously going to need a lot more time. A lot more time. So I'm going to go ahead. Do note, this graph according to Tox is kind of incomplete, so... Wait, I just want to see, are we... No, okay. Okay, chart title, I'm going to call this, graph of 2 trains. Okay. We know that the horizontal axis title, so this one is for time in seconds. And the other title here along the vertical axis is going to be, well, distances, okay? Okay. Now, obviously, I had to extend the time way past 3. But let's go ahead and do it. Let's go ahead and I'm going to see my... Okay, here we go. Series. Actually, let's go along the time axis or horizontal axis, and we need to see... Well, we need to go way into the future, so I'm going to go ahead and try... Funny, why are we starting at 1? You know what? I think I may need to adjust this. Yeah, that's what I was thinking. Okay, there we go. And we're going to go to... You see, the thing is, they don't start at 1 second. Okay, now I'm frustrated. I'm going to start again. You see, that is still not accurate. Okay, I'll be right back. Here's an important note. Never forget 0. Always start from 0. Okay, so that's kind of what I forgot. I'm going to insert one row above. I'm going to apply the same logic here. Basically, I think Excel is waiting for a 0 point. Obviously, at time 0, train A is still here at the station, right? And I think that's something we should have established, right? Another important value is that they leave at the same time, right? So it's the same time, and same time can be an important skill here. Oh, wait, no, I don't want to do that. So you notice it's leaving at the same time. So it means at time 0, both of these guys start. So that's an important value that we should take note of. So that's what we're going to do here. And same thing goes for here. Oops. Do it the other way. So at time 0, obviously we're at 0. Okay, so now we're going to graph this. Insert chart. You see, that makes a little more sense, and that's what it was waiting for. Okay, and again, I'm just going to go ahead and drag this down. Okay, I still have my drawing here, but I think I... Okay, and I'm going to set this up according to talks. Chart and axis titles, so vertical axis title, distance. Oh, it still remembers, thank you. It's going to be time. Chart title. It's going to be graph of 2 trains. Okay, and that's what we got. Okay, now obviously our timing though is way into the future, so we have to ensure that our horizontal axis can accommodate that. So we're going to actually have starting at 0. And you know what? Let's go to a reasonable value. Let's go to maybe, well, it's going to 60, right? So maybe if we go, no, 100 would be too much. Let's see. 6 times, 3,000, right? 6 times 50, right? So we'll go to 50. That's where the slower train is going to meet. And I guess we'll keep going to infinity. So we'll just go ahead. Maybe I'll have to change the chart. Not to a line chart, but maybe to a plot, scatter plot. And then allow it to draw trend lines here. And that way I can figure out where they're going to meet, even though I only have a few data points, and that way I don't have to keep guessing. Boom. Okay, there we go. Okay. Ooh, wow. Look at that. And this is the point I'm looking for. Boom. Okay, so I solved one problem. So we established when we did the 2 droids, right, that right here is their meeting point. And you can see this happens very cleanly. So we can answer one question right now. They meet at around 20 seconds, okay? These bullet trains are so fascinating. So 20 seconds later, they're meeting, okay? They're right here. That's cool. Now we need to figure out this point. Luckily, I can just go ahead and I can add or request more labels. You can actually do that quite easily in this. Here, I can show you how. So you see how we can ask for labels on the vertical axis, or grid lines and ticks. Do you see how that works? So yeah, we're going to ask for more grid lines. And yeah, so we're going to ask for maybe grid lines every, let's see, 20. No, maybe 50. Oh, wow. Okay, and you can see here, we actually have a clear value. They're going to meet at somewhere around... Oh, I actually may have to erase some of this stuff. So they're meeting at 20. And if it doesn't go quite as expected, yeah, they go here. And then after we're meeting somewhere around here, and you can see here, if I go ahead and trace my line straight, and I hope I am, we're meeting at near 120. So we have our two things, okay? So that's what, okay, so we meet at 20 seconds, very briefly. And then after one of them completes their journey here, around like 37 seconds later, the other one completes their journey here at like 40 seconds. And here we go. We got this one, 1,200. Yeah, and that's where we're going to meet up. Okay, which is cool. Okay, so we can use this value. So I'm going to actually just go ahead and scroll up, because this is actually not the answer to the question we want, right? I mean, the question is, so we know the time meeting, right? We know that it's going to be 20 seconds. Cool, right? And as I promised, not much algebra involved. You just need, as long as you had the equation, you were able to go ahead and do this. Now, distance from Eastford. Okay, well, that's easy because we set Eastford as our point. We know that's going to be 1,200 meters. Okay, no big deal. Tricky is how far from Westford. Okay, so well, we know that. Well, so we want to find this discriminant point here. So we know that this is at 2,600. You know what? We can just do some math here. So 2,600 minus 1,200, if you can do math in your head, or if you have a calculator right in front of you, that's 1,400 meters. Okay. And that's it. We're done. This is the answers. We did the two trains problem, and as I promised, we didn't have to do a system of equations or anything complicated. We just need to play around with the graph, do some algebra, and that was it. You know what? I realized something major. Don't make this mistake. I'm sorry, I'm not perfect. There you go. And you have meters. Okay. And there you go. You have your graph and everything else. Okay, so you guys are going to go ahead and try this with your own individual problem, as you see here. I think I've gotten the point pretty clear across. I want to thank you guys for paying attention, and I'll be posting this up on YouTube so you guys can see. All right, guys. See you later.